So I did a video about where is the electric field due to two charges equal to zero. So I'm going to do another video about where is the electric potential equal to zero due to two charges. Let me just say something about my channel, because some people come here and like, I don't even know what this guy's doing. So I'm a blogger and a physics professor, and I do some other things. This channel, I'm just working out a whole bunch of physics problems. Sometimes it's physics content. Sometimes it's just solutions. Sometimes just stuff I like to do. I definitely like to use Python whenever I can. And I just really like physics. So if you have questions, let me know. I try to reply, and let's get started. So let me turn off this video because I need more space. Okay, so here we are. Where is the electric potential equal to zero? So here I have two charges, Q1 and Q2, and they're on the x-axis. Now they don't have to be on the x-axis, but I put them on the x-axis because it just makes things easier, and you can imagine any other situation where it would still work. But let's just make it as simple as possible for now. Okay, so what is electric potential? This is the potential with respect to infinity. Technically, what we're doing is finding the potential energy with respect to infinity to bring a charge in, and then dividing by the value of that charge, and we get electric potential in volts. If I have a single point charge and I want to find the potential with respect to infinity at some point a vector r distance away, then it would just be 1 over 4 pi epsilon naught, which is a constant, times the value of that charge divided by the magnitude of the vector displacement to that charge r. You could also write this as V equals K Q over R, where K is the constant. K equals 1 over 4 pi epsilon naught equals 9 times 10 to the 9th newtons meter squared per coulomb squared. Okay, so now what if I have two charges? Well, if I want to find the electric potential due to two charges, I just sum them up. So V is going to be V1 plus V2. So I just need to find the potential due to each charge. Okay, let's start off thinking about just on the x-axis and then move off the x-axis. So here I have three regions. Let's call this A, B, and C. And I'm going to assume, let's just look at region A. And let's start with region C, right? Because C always gets messed up because it's last, so let's put this one first. If I want to be right here, let's write down, and these are a distance s away. So let's call this the value x. So if I want to, I could write V equals V1, which is going to be K times Q1 over this distance, which is x, plus, that's K1, K times Q2 over this distance, which is going to be x minus s. And we want that to be equal to 0. Okay, so no matter what in this region C, x minus s is going to be less than x. So in order for these two things to cancel, two things must be true. One, Q2 has to be negative Q1. If these are, this can't be negative because this is actually the magnitude of r, right? This can't be negative, it's the magnitude of r. And if I want to add these two things together, they have to be opposite charges in order to add up to 0. That's the only way that's possible. Two, since I'm dividing Q1 by a larger number, then Q1 has to be greater than the magnitude of Q2, right? And since this one's going to be closer to that point charge, it's going to have a higher potential. If you want these two to cancel, then this one's going to have a greater value. So we've already set right now there, I'm going to have Q1, let's say, be positive, Q2 be negative. The magnitude of Q1 has to be greater than the magnitude of Q2. That's the only way for that to work in region C. This is in C. What about in region B? Well, in region B, if I pick something like a location right there, I could say V equals the electric potential due to charge 1, K Q1 over X, plus K Q2 over, now X is going to be less than S. So really what I want to divide by is S minus X, because again, this is the magnitude of the displacement vector. and it has to be positive. You can't have a negative magnitude. So I need to really, I could put the absolute values around that and that'd be okay. But this is the way it's going to be here, and that's going to be equal to 0. So again, Q1 has to be equal to negative Q2. They have to be opposite signs in order to add up. However, they could be the same charge. If they're the same charge, just imagine if they're the same charge, then this potential point right there in the middle would be 0 because it has the potential due to Q1, potential due to Q2 is the opposite, and so the distance between them would be right there in the middle. But that is true for B. Now, in region A, let's assume I'm going to stick with Q1 is greater than Q2, the magnitude. If that's the case, there's no region over here that would be equal to the potential would be 0. Because if I pick a region, a location right here, then this is going to be closer to this charge, and that charge has a greater value, so the potential is going to be greater. There's no way it can cancel with this one, because this one's always further away. Okay. So let's say Q1 is greater than Q2 magnitude, and Q2 is negative, and I want to find the potential. There's going to be 2 spots. We'll call this x1 and x2 on the x-axis. So let's find those 2 spots. Let's first find x2. It's not too hard. Okay, so I said over here, let's redraw my picture. So that's S, that's Q2, that's Q1, and this is X. Let's call that X2. And that's where the potential is equal to 0. So V equals K times Q1 over X2 plus K times Q2 over X2 minus S equals 0. And I'm calling that X2. I should just call it X. I feel like just calling it X right now. But and that has to be true. Now, yeah, Q2 has to be negative, but I already said that. So let's just solve this for, let's subtract this from both sides. And I get K Q1 over X2 equals negative K Q2 over X2 minus S. The K's cancel. Now I'm going to multiply both sides by X minus 2. I'm going to multiply this side by X2 minus S over X2 minus S. And I got to do that to this side. And then I'm going to multiply this side also by X2 over X2. So I'm going to multiply both sides by that. So in this side, it's cross multiplying. I just don't like to say that. So I get Q1 times X2 minus S equals negative Q2 X2. I want to solve for X2, so let's get those to the other side. Let's multiply this out. I get Q1 X2 minus Q1S equals negative Q2 X2. Now I'm going to add this to both sides and add that to both sides. I get Q1 X2 plus Q2 X2 equals Q1 S1. Now I'm going to factor X2, Q1 plus Q2 equals, did I lose a minus sign? I don't think I did. And then so X2 equals Q1 S1 over Q1 plus Q2. Now let's just check. X should be a positive value. So I said Q2 is negative. And Q2 is greater, Q1 is greater. So this on the bottom is going to be a positive number. And this is going to be a positive number too. And should this be greater than S1, right? S1. What's S1? It's just S. I just got carried away with the S's. So here I have Q1, and this is going to be smaller than Q1, because remember Q2 is negative, so I'm multiplying this by a fraction greater than 1, so it's going to be greater than S. So that's cool. That works. Okay, so now let's find X1, which is in between the two. So really the only thing I need to do up here is switch the order of these two. So I have, again, the K's are going to cancel. So I get Q1 over X2 equals Q2 over S, that's X1 now, S minus X1. Cross multiply again, Q1 S minus X1 equals Q2 X1. Now I'm gonna subtract this from both sides, right? To get this over here. So I get Q1 minus Q2. No, this is multiplied out. I get Q1S minus q1 x1 equals q2 x1. Let's add that to both sides. So I get, I'm running out of space here, and I want to solve it, so I get x1, I'm just going to do it. x1 is going to be equal to, add that to both sides, so q1 plus q2, I get q1s divided by q1 plus q2. It's the same thing. I made a mistake. See, this is what happens when we try to squeeze it all in. Let's just start over. Make sure I get that right. So I have this. 0 equals q1 over x2 plus q2 over s x1. S minus x1. So q1 over x1 equals negative q2 over s minus x1. Now I'm going to cross multiply. I just did it too fast. I get q1s1, q1s, minus q1x1 equals negative q2 x1. Now I'm going to add this to both sides. I get q1s equals q1 x1 minus q2 x1. q1s equals x1 times q1 minus q2. So x1 is going to be q1s over q1 minus q2. Okay, and then my other solution was x2 equals q1s over q1 plus q2. Okay, perfect. So let's just check right here. Remember, this is q2 is negative. It's a negative number. So if I add q2 plus q1, this is going to be a number greater than q1. So when I divide these, I do get a number that's smaller than s. So that's good. And this gives me a number greater than s. So this is smaller than s, greater. Okay, so those are my 2 points. Great. Now, what about all the other infinite number of points where the potential is 0? We're going to need those 2 in just a second, though. Okay, so let's go back over here. Here's q1. Here's q2. There's x1. And there's x2. But what about the other points, right? Because I can imagine if I am right here, if I want to find my observation location right there, this is the vector r1. This is the vector r2. So I have v equals k q1 over the magnitude of r1 plus k times q2 over the magnitude of r2 equals 0. Is that possible? Yes. And when I did this for the electric field, that was not possible because the electric field was a vector and there was no way these two vectors could add up to 0 because it'd be in different directions. But the electric potential is a scalar, so there is a way for them to add up to 0. Okay, so let's just get an expression. Let's call this the point xy. So the magnitude of r1 is going to be equal to, this has a coordinates of just xy, so it's going to be the square root of x squared plus y squared. This has a coordinate, this vector, since I already went over a distance x, r2 is actually the vector, this is actually going to be magnitude, the square root of x minus s quantity squared plus y squared, right? Because that has a different value. If r2, if this x was s, then that would be 0 and it'd be straight up. Okay. So if I put this into my formula, I get v equals k q1 over r1, which is the square root of x squared plus y squared, plus k q2 over the square root of x minus s quantity squared plus y squared equal to 0. So let's just, the k's cancel, okay? And I'm going to subtract that from each side. So I get q1 over the square root of x squared plus y squared equals negative q2 over the square root of quantity x minus s squared plus y squared. Now, you see it's already more complicated, but we, of course, know tricks. Everyone knows some tricks, right? So I'm going to square both sides of this, and I get q1 squared over x squared plus y squared. Doesn't that look better? Equals q2 squared. It was negative squared, so that squares, over x minus s quantity squared plus y squared. Now I can cross multiply, and I get q1 squared times x minus s quantity squared plus y squared equals q2 squared times x squared plus y squared. Okay, I want to make this simple. So let's divide both sides by q1 squared. And then I'm going to call 1. And then I'm going to call this c equals q2 squared over q1 squared. It's just a constant, right? And that way I just have a constant there and I don't have a constant over there. It just makes my algebra a little bit less messy, tidier, more tidy. Okay, so now I get x minus s squared plus y squared equals c x squared plus c y squared. Remember, c is this is q1 squared over q2 squared, q2 over q1. Okay, I want to solve for y. So let's multiply this out. I get x squared minus 2xs plus s squared plus y squared equals c x squared plus c y squared. Okay, so now I want to get all the y's on one time. So q2, let's just think. q2 squared over q1 squared is less than 1. Right, because q2 is smaller than q1. So if I'm going to subtract this from each side, and I get y squared minus cy squared, and I'm going to move these terms to the other side, equals c x squared minus x squared plus 2xs minus s squared. So here I get y squared times 1 minus c equals x squared times c minus 1 plus 2xs minus s squared. Y squared equals x squared times c minus 1 plus 2xs minus s squared. All of that over 1 minus c. And that's my answer. That line, that equation, this equation tells me that if I know the x value, then I can find the y value for where the potential is 0. Now, but remember, here's charge 1, here's charge 2, and here's my 2 locations where the potential is 0. But there's not going to be a solution over here. There's not going to be, so it's actually just this region between these two where I could possibly get an answer. Okay, so what I'm going to do is plot this function from x1 to x2. If I don't, I'm going to get, if I'm over here or over there, I could get a negative value up here, which then I can't take the square root of. So if I take the square root, I'll get a positive answer, and I'm going to plot that. But let's just do this. So I'm going to use my values here. I think I used it before. Let's say q1 equals, I would need to be greater, so let's say 2 times 10 to the negative 9th coulombs. q2 equals 1 times 10 to the negative 9th coulombs, and s equals 0.1 meters. So I need to do, I'm going to switch over to Python and plot this. I need to do a couple things. I need to calculate x1 and x2, the locations of these, and then I'm going to plot this curve, and then I'll do it, and I'll plot it again for the negative side. So let's switch over here to Python. Come with me. Come on. Come with me. We're moving over here. Okay, so I switch to computer view, and there we have it. Because I'm using Glowscript v Python, I guess I should save this. 0 potential plot 1. I think I had another one, so I'll save that. Okay. Let me move the mic a little bit. Okay, I feel better now. Okay, so let's put in my values. K equals 9 times 10 to the 9th. Actually, I don't even need that. Q1 equals 2e to the negative 9th. Q2 equals, what did I say? -1 e to the -9th. S equals 0.1. So let's first just calculate x1 and x2. x1 is going to be equal to, I'm just typing it in here, q1 times s divided by q1 minus q2. Print x1 equals x1 meters. And then x2 equals q1 times s divided by q1 plus q2. Print x2 equals x2 meters. Save. Is that big enough? Can you see that? Okay, and then I'm going to run it. Okay, so I get, let's just check, right? I had the distance of 0.1 meters, so x2 is greater than 0.1 meters. Check, that's a good thing. x2 is in between those two, and closer, remember halfway in between them would be 0.05. It's closer to the smaller charge. Everything looks like it's working. Okay, so now I need to calculate these y values. So the first thing I'm going to do is actually make a graph. So let's say t graph equals graph, x title, I should give a title. Title equals 0 potential points. The x title is going to be equal to x title, and it has units of meters. The y title equals y meters. Oops. Okay. Now I'm actually gonna have two graphs here. So I'm gonna say FP for positive is a graph type G curve. I will include a link for graphing tutorial. I should make a better one. My graphing tutorial is not the best. G curve color equals color dot blue. Blue's my favorite. Fn is the negative curve. G curve color equals color dot blue. Okay, so now I'm going to start off with x equals x1, dx equals 0.001, and now I'm going to say while x is less than x2, then what I want to do is I'm going to calculate y, I'm going to plot y, and then I'm going to move my x value up a little bit more. So I'm just going to type in my y equation over here. Where'd I go? Okay, I'm moving my paper so I can see it. So y, I need c. Remember that? Let's put it up here. C equals, what did I say it was? It's q2 squared divided by q1 squared. Isn't that right? Yep. Okay, so now I just need to type my equation. So I can say y equals square root x squared times c minus 1 plus 2 times x times s minus s squared. I need another parenthesis in there. Divided by, divided by 1 minus c. Now I need another parenthesis. Yeah. And that will give me my y values. Now I need to plot that. So fp dot plot. The x coordinate is going to be x. The y coordinate is going to be y. And then I need to add, this is the part I always make mistakes on. It makes me really mad. X equals x plus dx. And let's just see what happens. That I don't want to do the rest until the thing works. And it might not work because I make mistakes. Okay. Boom. It worked. Oh my gosh. I feel like Anakin Skywalker in The Phantom Menace, where he gets his pod racer working and he gets all excited. Okay. So now I need to do the negative values. So let's say x equals x1. And then I'm going to do the exact same thing. Except I'm going to change this to fn, and I'm going to change this to negative y. And I'm going to save it. and my graph's too big. So let's change the size. Width equals 400. Height equals 300. Let's see if that will make it. It's my own fault for making the thing zoom. There we go. Check that out. And that's not 0, right? That's where all the potentials are equal to 0. Let's just put in our 2 points just for fun. Let's say down here, FQ equals G dots. Radius equals 5. I think that's right. I think the standard radius is 3. G dots is a way to plot things, but it just plots points. So now I'm just going to say FQ dot plot, and I'm going to say the first point is at 0, 0, and then FQ dot plot. The second point is at x equals s, y equals 0. That way we can see those 2 charges as dots. Yeah, there we go. Check that out. You like that? Okay, let's just one more thing. What if I change these values to, let's make this one -1. Let's keep that at 1. Let's keep let's increase this one at 3 and run it. Okay, so you skipped right here, and that's fine just because my value is really small, but I think it's still working. I think I can fix that by making a smaller distance step. Okay. So that's it. Now, there is another way to find these that I have an idea about, and I'm going to do that later. But this is kind of fun. Okay. I'll talk to you guys later.